Okay, so let's review the labs 14, 15, 16. So let's take a look. You need to label which compounds are acid-based or salt. Obviously you have two acids, a base, and a few salts here. So acid, of course, that is more ionized will react more quickly because it has more hydrogen ions available. The purpose of titration is to determine the concentration of either the concentration of either acid or base, depending on what you titer. So how do you figure out the neutralization reaction? Acid-base. It's got to be acid-base. Okay. So if you so technically speaking, only C is a neutralization because pH is equivalent to 7. E is neutralization, no pH, but this can happen as well. It can be neutralization, but there's still some residual base. You need to balance it. That you can do by yourself. Molarity when 10 milliliters of acid is brought to pH 7. I don't really understand what molarity of what. This question makes no sense at all. What's the What's the molarity of acid? I understood. Okay, so this is fairly easily calculated. You have 20 milliliters of 0.1 molar base and 10 milliliters, so half of the volume of acid that is neutralized, which means the molarity of acid has to be twice as much as the molarity of base, so 0.2. Buffer is the solution that can maintain pH when small amounts of acid or base are added. Buffer consists of a weak acid and its conjugate base, or a weak base and its conjugate acid. Now, if buffered solution of pH 9 has little acid added to it, nothing's going to happen. pH is going to be maintained. When blood pH drops below normal, that's acidosis. So why the pH could decrease? Because the capacity of buffer to maintain the pH is exceeded. Bubbling in lab 15 experiments 2. You mix bicarbonate with hydrochloric acid, results in the production of carbonic acid, which then dissociates into water and CO2.